We want to take a look at solving a rational inequality. We're given a function f of x is 2x minus 3 divided by the quantity x minus 1. If you'd like, you can feel free to put this into a graphing calculator. We have a sketch provided, and we're going to be solving these graphically. Taking a look at our first equation, we'd like to know when is f of x equal to 0. F of x, would exactly be 0 wherever the graph hits our x-axis. We have on our graph our asymptotes, the vertical and the horizontal labeled, but I can see the function value where x hits. Looks like it's between 1 and 2, so we can say that x is equal to 1.5. Or we can simply call it the fraction 3/2. And if you like, you could always use your graphing calculator to figure this out. We have the graph provided. We can use the best estimate based on what we see. In order to solve the inequality then, when is f of x less than or equal to 0? Keep in mind, when we're looking at an inequality, the function value below 0 would be the function values that are less than 0. So we want to know when is f of x less than or equal to 0. We really want to know when are there function values below 0. And on my graph, I can see that the function values are below 0 as we approach this asymptote. Now we do need to be careful here. Our function values don't scream all the way to the left, so I cannot just say x is less than 1.5 or x is less than 3/2 because we have our asymptote there. So all I can say is that there is a value x such that x is between the number 1 and the number 1.5 or 3/2. Now our inequality did contain the equal to part. Because it was less than or equal to 0, then I can say x is any value between positive 1 and 3/2. It does include the 1 and it does include the 3/2. So if we write our answer in interval notation, our answer in interval notation would contain every value starting at 1 and going to 3/2. At 1 we have an asymptote. It cannot equal 1. Oh, so sorry, inequality. We do not have equal to when we get approaching the number 1 because that is where our asymptote occurred. We will definitely have a parenthesis in this case. Now, where x is 3/2, we do have equality because that is where it's equal to 0, and so we will definitely have a bracket at 3/2. So notice this was not all values that were less than 3/2. It was only the values starting at 1, not including the number 1, and going to 3/2. But we are including the value 3/2 itself. For our third inequality, we're interested in where is f of x greater than 0. And so for us, this really just means when is f of x, our function value, above 0. So what values of the graph give me something above 0? And again, we need to be careful here. Our values of x do start at 3/2. I get values of x, and they are screaming all the way to the right, all the way to infinity. So I know half my answer is all the values of x, where x is to the right of 3/2. Or we can also say the left side of the curve, don't forget him, he's above the asymptote, but you know what? All of those function values are definitely above 0. So this is all values of x that are to the left of the number 1. Because of the asymptote, we are not including the number 1. The fact is, because of the inequality, it didn't have an equal to part, we wouldn't be including the number 1 anyway. But these are all the values that are to the left of the number 1. Therefore, all the values that are less than 1. We can write this in interval notation also. Interval notation from left to right, everything that's smaller than the number 1 would be all the values from negative infinity, and immediately on negative infinity I put my parentheses because I know we will never reach negative infinity, all the way to the number 1. At the number 1, we are not equal, also carries the parenthesis. What we were noting here is the left side of the graph, the one that went from negative infinity all the way up to the asymptote. Or we denote with our union symbol, because again, once we hit that number 3 halves, we're at 0. So starting from 3 halves and going all the way out to infinity, I know immediately we have that parenthesis at infinity. We will never reach it. But because this was not greater than or equal to, it was strictly greater than, we will not include the value 3 halves either. So it also will carry a parenthesis. So our solutions to where is f of x greater than 0, everything that's above 0, from negative infinity to 1, and from 3 halves to infinity. All right.